Assalamu alaikum, dear students. I'm your course instructor, Dr. Mazullah Khan, and I welcome you to my video lecture number 23. Today, we will talk about the last bits of chapter number 8, which is rate of return analysis for multiple alternatives. Before I do that, let me give you a quick recap of my last lecture. So, if you remember, I give you a very simple example in which we were comparing a decreasing cash flow project with an increasing cash flow project. And I asked you a very simple question that if we rank these projects based on IRR, project D is feasible. It is more preferable. But if we compare the projects based on PW, project I is selected. So the thing that I wanted to convey with these two examples, in another example, if we are considering the individual project return, rate of return, we will choose project A or project B. But if we are considering the overall return of project A, and from overall return, we mean that we are utilizing the available capital. So we invest whatever is required in project A, and the remaining we invest at MARR. So if I compare the overall rate of return for project A, it is 26%, 26.6%, and that of project B is 28.3%. So the main reason I give you these two examples is to introduce you to a situation where there exists a ranking inconsistency. So if I rank project based on IRR, project D is selected. But if I choose PW as a selection for selection decision, I choose project I. Similarly, if I use individual rate of returns, I choose project A. But if I use overall rate of return, then I choose project B. So there is a phenomena what we call ranking inconsistency. Okay, so ranking inconsistency exists between two different analytical tools, or even within, let's say, if I'm using rate of return, it really depends whether I'm comparing project rate of return versus overall rate of return. Then in order to tackle these problems, I introduced you briefly to a technique. It's called incremental cash flow analysis. So incremental cash flow analysis essentially is a technique which tells you that if the extra investment, or in one of my slides, we said not the unavoidable, but in fact avoidable investment is justified. Okay, so whatever extra investment is required, let's say if I'm choosing project B or project A, is that extra cost or extra investment justified? Now, today we will cover, as I said, the last bits of chapter number 8. So there are three primary elements due to which mainly IRR analysis are applied incorrectly in engineering economics. Incremental cash flow series, the least common multiple method, and then the multiple roots or the multiple IRR values. And do not worry about these. I'll give you a numerical example and then it should be crystal clear for you. It is advisable to use PW or AW analysis, okay? So PW and AW, they are similar techniques, okay? One is present worth and the other one is annual worth. And in chapter number 6, I told you that PW and AW actually yields into same decision. So if I choose a project based on PW, if I'm using, let's say, AW, it wouldn't change my decision because these are two similar techniques. They are not identical, but they're similar. Okay, So IRR evaluation by using PW. Okay, so calculating IRR for single alternative, we take PW and equate it to 0. Okay, and similarly, PW based relationship is developed for incremental cash flows and set equal to 0. Okay, so while calculating the IRR, of course, by definition, IRR is the rate at which your PW is equal to 0 or your AW is equal to 0. And then in order to calculate IRR, of course, we use trial and error approach or interpolation, and we calculate the IRR. If the projects have, let's say, different lives, so if the alternatives are different life alternatives, what we do, we use LCM method. So if one project has 6 years of life and the other project has 9 years of life, then of course the LCM is 18. So we repeat, we in fact consider 3 cycles of this project and then 2 cycles of this project. Okay, we covered this technique in previous chapters. It's a very, very easy technique to implement. So nothing too special about that. If I'm evaluating IRR for 2 mutually exclusive alternatives, there are few steps that we need to follow. And these steps, once I give you a numerical example, they are straightforward. Okay. The first step is that I have to order the alternatives by increasing initial investment. Then the second step would be, okay, to develop incremental cash flow series using the LCM of years. Okay. Then the third step would be, so the first step is of course ordering. So order the cash flows. Second step would be calculate the incremental cash flows. And if there are different life alternatives, then we use LCM approach. Okay, draw incremental cash flow diagram, okay, if required, and count sign changes to see if there are multiple, let's say, interest values, IRR values, if they exist. Set up PW, AW, and FW equal to 0. Okay, this is how we define IRR. Step number 4 is Descartes' rule. Okay, so if there are, let's say, 2 sign changes, there are up to 2 solutions. And if I'm saying solutions, it means that there may exist up to 2 IRRs. Okay, then our task is actually to convert those 2 IRRs into a single IRR. Okay, we have already done that. Okay, that's not a big deal. Incremental rate of return analysis require equal service comparison. Okay, so as I said, if one project has 6 years of life and the other project has 9 years of life, we cannot simply compare them. The only way we can compare them is through LCM method. Okay, so we have to take into consideration the LCM method. Then once I calculate the incremental cash flows in step number 2, I calculate the IRR for incremental cash flows and then see if it is more than the MARR. Okay, we select project B. Okay, so I subtract all the cash flows from B. Okay, so I subtract all cash flows pertaining to project A from project B. Okay, and then I see whether the additional cost is justified. And how do I do that? I compare the internal rate of return of the incremental cash flows, which is here, okay, and compare it with MARR, which is actually my benchmark. Okay, if it is more, of course, it is justified. So we prefer project B or project A. But let's say if it is otherwise, so suppose if it is less than MARR, then we go for project A. If the projects are, of course, mutually exclusive. In mutually exclusive, let me repeat myself, we have to pick one project. And these are normally cost alternatives. And I gave you an example in my last lecture. For example, if the government wants to build a highway, okay, regardless of the fact if it's okay, let me choose my words properly. Okay, the government compare bids, and of course, whose bid is the cheapest one, they go for it because these are cost alternatives. Another example is, for example, if you are a finance manager in a textile mill, let's say in Faisalabad, and you would like to replace a weaving machine, okay? You have different alternatives on the market. You will choose an alternative which is justified. And from justification, I mean that, let's say, if you are paying more money in terms of initial investment for an alternative, that additional cost should be justified. Okay, so the benefit of the additional cost should be more than the, sorry, let me repeat. So the benefit associated with the alternative should be more than the cost associated with the alternative. Okay, in simple words, we simply compare the IRR of the incremental cash flows with MARR. Okay, because MARR is my benchmark. Just like other cash flows, if there are multiple values of these incremental cash flows, like IRR associated with the cash flows, we have to use EROR technique. And there are two techniques. One is the modified rate of return or the return on invested capital approach. We already covered that. Okay, so even if I'm using incremental cash flow approach, there may be multiple IRRs, and in order to tackle that problem, we have to resort to EROR method. Okay, and there are two methods, as I said. Okay, so for internal rate of return, IROR, or in simple words, IRR evaluation, if I'm using the AW method, so what happens? Okay, it's straightforward. IRR, by definition, as I said, is the rate at which your PW is equal to 0 or your AW is equal to 0. Okay, so these two are similar techniques. And again, they are not identical, but they are similar. For incremental cash flows, we do exactly the same thing. We discount all the incremental cash flows and put the present value equal to 0. Okay. Similarly, we calculate the AW of all incremental cash flows and equate it to 0. Okay. I wouldn't do the AW method because it's straightforward. We already learned that technique. I'll talk about more of the approach, that how do we do incremental analysis. So in incremental analysis, even if we are comparing 3, 4, 5, or 6 projects, okay, we do comparisons pairwise. So at one point in time, I'm only comparing 2 projects at a time. Okay, I choose one and I reject the other one. Okay, whatever I choose, then I compare it with another project. Okay, so it's a pairwise comparison. Okay, so let's start and see how does a pairwise comparison work. So let's take this example. Either of the cost alternatives shown below can be used in a chemical refining process. If the company's MARR is 15%, determine which should be selected on the basis of ROR analysis. So there are two cost alternatives. Alternative A, the first cost is minus 40,000. The annual cost per year is minus 25,000. Salvage value is 8,000, and the life of the project is 5 years. Like the service life of this alternative is 5 years. Alternatively, alternative B has an initial cost of $60,000 and then an annual cost of $19,000 per year and salvage value of $15,000. My initial observation is that both the projects are mutually exclusive because these are cost alternatives, and these are cost alternatives, by the way, and they have equal lives. Okay. Now, first step. My first step is order these alternatives. You start with the lowest cost alternative. Okay, so this should come in the first column, and the second column would be my second highest alternative. Okay, so instead of alternative A, if I'm choosing alternative B, it requires an additional investment of minus $20,000. But the benefit is that I'm saving $6,000 in annual cost per year, and then I'm saving an additional $2,000 in salvage value. Okay, so first step, order the alternatives. Second step, find the differences. So calculate B minus A. Okay, so 60,000 minus 60,000 minus 40,000 is equal to minus 20,000. And similarly, minus 19,000 minus 25,000 is 6,000. Okay, so the second step is calculate the differences. So this is the first step. Okay, now write an ROR equation for the incremental cash flows. Okay, so these are my incremental cash flows. So as I told you in my last lecture, whenever we see a word increment, normally we are talking about differences. Okay, and when I set this equation, that at what rate, so let's say the rate is delta I. Okay, so this is unknown. At what rate the present value of these incremental cash flows will be equal to 0. Okay, we can easily use Microsoft Excel and use actually a spreadsheet function and easily calculate the delta I. Or let's say if you do not have access to computer, you can use interpolation. Okay, we have already learned about both techniques. So if delta I is 17.2%, it will make the present worth of all incremental cash flows equal to 0. And by that definition, actually, it will be the IRR of B minus A. Okay, so this is the IRR of the incremental cash flows. Okay, and since 17.2% is more than 15%, because 15% is my MARR, okay, so the investment of additional, so the additional investment is actually justified. Okay, so B is selected. Okay, assume a situation, let's say, if the IRR of these incremental cash flows would have been less than MARR, then of course we would have gone with project A. So alternative A would have been more desirable. Okay, so straightforward, no rocket science. Okay, now let's go to a situation where the service lives of both alternatives are different. Okay, so we cannot, it's not that straightforward now. It's not complicated, but of course I have to go through LCM method. Okay, so the first cost of project A is minus 50, the annual cost is minus 100,000, and the salvage value is 5 years. The service life of alternative A is 3 years. Project B, 95,000 is the initial investment, the annual cost is 85, and the salvage value is $11,000, and it has 6 years of service life. So easy solution. As you can see, the LCM of 3 and 6 is equal to 6, which means that I have used 2 cycles of project A and 1 cycle of, so 2 cycles of project A and 1 cycle of project B. Okay, so this is the cash flow diagram. Okay, initial investment, as I said, minus 50, minus 100,000 is the annual cost. Okay, and this is the salvage value. Okay, in purple. Now I have to repeat this cycle. So as I told you in one of my lectures, it's just copying the cash flows associated with the first cash flow and paste it. So I copied this, pasted it here. Okay, these are the cash flows for project B. Okay, my next task is to calculate the incremental cash flows. Okay, so I have already ordered them. Okay, this is a low cost alternative, project A, and project B is a high cost alternative. So let's find out the differences now, B minus A. Okay, so minus 95 plus 50 is minus 45. 15,000 is the difference between minus 85 and minus 100. Again 15,000. And now what I'm doing is actually I'm calculating the difference between this minus 85 and this minus 100, which is 15,000, and the difference between this minus 50, sorry, this here it's 0, minus 50, and then minus, so the difference between this 0, okay, and these two numbers in purple is actually $45,000. Okay, so it's actually 0 minus into minus 50K and then minus 5K. Okay, sorry, plus 5K. Okay, so this is minus into minus 45K equal to 45K. Okay, so this is straightforward. You calculate the differences, but the reason I did it this way because it's much easier to use, let's say, PA factor now. Okay, so the present worth of this cash flow, this incremental cash flow is minus 45,000, which is from here, and this minus 15,000, I multiply it with the PA factor, okay, for 6 years. Okay, this delta I is unknown. This is what is required. Minus 45,000, and then I have to use a PF factor. Okay, delta I again is required, and then plus $6,000 PF delta I and 6 years. Once I use Microsoft Excel or let's say interpolation method, my delta I is 42.5%. Okay, which is much higher than MARR. So what do? I choose alternative B. Okay, so the whole point is if both the project has multiple, not multiple, but different lives, we have to use LCM method. That's the whole point. Okay, so we learned about the incremental cash flows of two alternatives, okay, and it's IRR. Now, what happens, let's say, if I have more than two? Okay, as I said, even if we have multiple alternatives, like more than two alternatives, we still do pairwise comparisons. Okay, so we order the alternatives, okay, see if the IRR associated with incremental cash flows is greater than or less than. Okay, I apologize, this has to be greater than or equal to MARR. Okay, I'm sorry, this is less than, that's fine. Okay, if it is less than MIRR, it is rejected. It means that B is out. Okay, okay, so same thing. If IRR of B minus A is greater than or equal to MARR, okay, B is accepted. Okay, if it is less than that, B is actually rejected. If it is rejected, it means that we have to go with the alternative. So if I'm comparing B with A, then I go with A. Okay. Now, how do we compare alternatives? So there are different terminologies here. So alternative lowest initial investment, in the analysis, it is called defender. Okay. But there is another alternative which has the second lowest investment. Okay. It's challenger. Okay. So let me go back to my previous example. For example, let's say equal life alternatives. So in this particular situation, this will be defender, and project B is actually challenging project A. So this is challenger. Okay, that's the whole point. So the lowest investment is defender and the second lowest is challenger. But please remember that at one point in time, I told you that do nothing is also an alternative. Okay, so I always start with DN as a defender, okay, because DN involves zero investment. So it is the lowest investment. So that's why it's a defender, okay. And then I compare it with the second lowest initial investment, okay, and decide whether DN is preferable or the alternative is preferable. Okay, and then I make those decisions accordingly. So make the cash flow of defender and challenger, check incremental cash flow. Okay, so we compared, as I said, we do pairwise comparison. So my first task is, if it is economically viable, select challenger. Okay, if it is economically viable, so let's say if IRR of B minus A is greater than MARR, okay, so it is economically viable, so I will choose actually the challenger. And then the challenger will be compared with the next one, okay, and in the next comparison, challenger becomes actually the defender. Okay, this is like a very abstract terminology, but example, once you see it, it is straightforward. Okay, so let's go to the example. I'll get to the example actually on the next slide. Okay, but how does it work for mutually exclusive? So this ME is for mutually exclusive multiple alternatives. We order the alternatives. Okay, how do we order them? From smallest to largest initial investment. Okay, for revenue alternatives, we calculate the I star and we compare it with DN. Okay, and eliminate all with, let's say, if the calculated rate of return is less than MARR. Okay, then I just discard it. Remaining alternative with lowest cost is defender. Okay, for cost alternative, if there are cost alternative, then we have to skip to what's this called, from 1 to, we will skip from step number 1 to step number 3 directly. Okay, so what is step number 3? Determine incremental cash flows. Okay, so we will determine the incremental cash flows between the defender and the next lowest cost alternative, the challenger. Set up the ROR relation. Okay, we can use either PW or AW for that. Okay, calculate the rate of return of incremental cash flows, okay, between the two alternatives, compare, okay, eliminate defender, and challenger becomes new defender against the new alternative on the list. Okay, and we will repeat step 3 to 5 until only one alternative remains. Again, as I said, this looks very abstract, but example straightforward, plain vanilla. Okay, let's go. So suppose I have 4 different alternatives to choose from. Okay, so alternative A involves $200,000 initial investment, alternative B 275, C 190, and D 395. Okay, and the annual inflows per year would be 22,000 for project A, and then 35,000 for project B, 19,500 for project C, and 42,000 for project D. Okay, the good thing is all 4 alternatives have equal lives. Okay, so first thing first, okay, So how do we do actually comparisons? All sites have a 30. These are actually sites. Okay, so a plant engineer has identified 4 different locations. Okay, so these are locations A, B, C, and D. Have 30 years life, and they are revenue alternatives. Why revenue alternatives? Because the company invests initially, and then they are expecting inflows. So that's why they are revenue alternatives. Okay, the procedure outlined above is applied. The alternatives are ordered by increasing initial cost. Compare C with the do nothing alternative, and RR relation includes only the PF factor. Okay, let's do that actually. It's straightforward. So this is the first step. I'm doing nothing but actually ordering all the alternatives based on initial investment. Okay, so C is the one which needs the lowest investment. It's minus 190. Okay, the second lowest would be 200,000. The next would be 275, and the third one would be 350. In other words, project D is the cost. It will cost the most to the company. Okay, but of course, its ability to generate profit is high. Okay, these are the cash flows associated with each project. So my first task is, of course, ordering. I already did that. My second task is to compare. Okay, so C is actually a challenger in this situation. Okay, and it is challenging the do nothing alternative. Okay, so C is compared with do nothing. Okay, do nothing means zero investment and then zero revenues. Okay, if I do nothing, it means that I'm not investing anything, and of course if I do not invest anything, I do not get anything, so zero revenues. Okay, so the net cash flows would be same cost and same revenues. Okay, if I calculate the PW like, for example, let's say, how do I calculate the PW of this alternative? Okay, so the PW of this alternative would be minus 190,000. Okay, this is the PW, the initial cost, and then plus 19,500 is actually the annuity, and I'll use PA factor. Del I is something that I'm interested in, and then 30 is the number of years, and then of course I equate it to equal to 0. So what rate will make all the cash flows equal to 0? The present worth of all cash flows equal to 0. Okay, so as I said, the incremental cash flow, if I compare C with DN, okay, is minus 190,000, and the incremental revenues, if I move from DN to C, is actually 19,500. Okay, so this is the what is called the PW of cash flows. In fact, the incremental cash flows. Okay, so my task is to calculate the delta I. At what rate this cash flow, the present worth of this cash flow, will be equal to 0. So if I use my Microsoft Excel, okay, or I use interpolation technique, it is 9.63. Now my next task is to compare the incremental cash flow with MARR. MARR in this question was 10%. Okay, as you can see, the IRR associated with incremental cash flow is 9.63, which is less than MARR. It means that C is eliminated. Okay, so if I compare C with do nothing, okay, I prefer do nothing. Why? Because the MARR of my incremental cash flow is less than MARR. Okay, so what it really means that if I execute project C, I will actually make losses. Why losses? Because my IRR associated with incremental cash flow is less than MARR. Okay, so C is eliminated. So once C is eliminated, of course I choose DN. So my next task, because DN is now the defender, okay, so DN would be a new defender, and I will compare it against A. Okay, I will do exactly the same calculation. Okay, I'll do exactly the same calculation. All right, and I will calculate the IRR of incremental cash flows. Okay, and how do I do that? I do that, I calculate that, and it turns out to be 10.49, which is greater than MARR. Okay, it means that A is justified. Okay, so I will choose A, and then I will eliminate, do nothing. My next task is to compare actually A with B. Okay, A with B. So B is my new challenger, and A is defender now. Okay, based on incremental cash flows. So how did I calculate the incremental cash flow? Of course, the incremental cash flow is 75,000 is the difference between minus 275 and 200,000. Okay, and the difference between 35 and 22 is my incremental inflows. Okay, if I calculate the IRR, it is 17.28%. Okay, it means B is justified. Okay, so I choose B. So my next task is I compare B with D. Okay, B with D. And as you can see, my incremental cash flow, the difference between minus 350 and minus 275 is again 75. Okay, and the difference between plus 42 and 35 is actually $7,000. Okay, and once I calculate again the IRR for incremental cash flows, it is 8.55, which is less than MARR, which means D is not justified. If D is not justified, it means we choose B. Okay, so B is my only alternative. So it is a straightforward technique. What do we do? Number one, we order the alternatives. Okay. Step number two, I compare the first alternative, the lowest cost alternative, with do nothing. Okay, and then I pick one. Whatever I pick, I compare it with the second alternative. Okay, I compare both of them, pick one, and then I compare it to the third alternative. Okay, so it is always pairwise comparison, and I keep on choosing the most beneficial alternative. I complete the whole cycle, and then I end up with choosing only one. Okay, so that's the technique that we will be using for multiple mutually exclusive alternatives. From mutually exclusive alternatives means that out of 4, we have to choose one. And by doing this analysis, we end up choosing project B. And as you can see, it is the alternative which is giving actually the highest return. I will stop here. In my next lecture, what I'll do, I'll pick one question from chapter number 7, and I'll pick few questions from chapter number 8. Those will be essentially the what is called the chapter end problems. Okay, and we will do some practice. I thank you very much for your attention. If you have any questions, please do not hesitate to email me those questions at mazullah@gkey.com. I wish you all the best. Enjoy your long weekend, and hopefully I'll see you next week. Assalamu alaikum.